Hello everyone, in this video we will learn about shortest job next CPU scheduling algorithm. So what is this shortest job next? So simply we call SJN. So sometimes questions may ask like this by using SJN or shortest job next also. So this is also known as shortest job first or SJF. So both names are same, shortest job next or shortest job first. So SJN or SJF. This is a preemptive scheduling algorithm. So shortest job first is a preemptive scheduling algorithm. Whenever required, so we need to stop the execution of one process and we will start another process's execution. So that's why shortest job first or shortest job next is a preemptive scheduling algorithm. Best approach to minimize a waiting time. So this shortest job first is used to minimize the average waiting time. So this is one of the best approach. Easy to implement in batch systems where required CPU time is known in advance. So whenever the CPU time is known in advance, means in advance if we know the CPU time, then we will easily implement this shortest job first algorithms. Impossible to implement in interactive systems where required CPU time is not known. So this is one drawback with shortest job first. So what is that? It is impossible to implement in an interactive systems whenever the CPU time is not known. Whenever the CPU time is not known, so it is very impossible to implement this shortest job first scheduling algorithms in interactive systems. The processor should know in advance how much time process will take. So the processor should know in advance. So in advance only the processor should know about the how much time it will take, means how much time the process will take. So here we will consider one example for a shortest job first. So by using this we will calculate the waiting time of each and every process and the turnaround times, along with that average waiting time and average turnaround time. So for that it requires processes and its arrival and burst times. So here we have four different processes are there. One is P0, P1, P2 and P3. So these are the four different processes and their arrival times and burst times are: for process P1, P0, arrival time is 0 and burst time is 6, and for process P1 the arrival time is 1 and the burst time is 8, and process P2 the arrival time is 2 and the burst time is 7, and for process P3 the arrival time is 3 and the burst time is 3. So here burst time means total execution time required for means the time required for execution of the process. So by using this arrival time and burst time, we need to calculate the waiting time of each and every process and the turnaround time of each and every process. So for that it requires Gantt chart. So for calculating the waiting times and for calculating the turnaround times we require the Gantt chart. So how we will draw the Gantt chart? So here the algorithm is shortest job first. So while draw the Gantt chart GC, so here we need to consider the least executing time period of a particular process first. So whenever we consider the burst times 6, 8, 7 and 3, which one is having the least value? So the process P3 is having the least value. So it will start at 0 arrival time, and how much time it will execute? It will execute up to 3. So like this we will represent the Gantt chart. So now we will consider the next least value. So what is the next least value here? 6 is the next least value. So that's why P3 P0. So P3 is starting at 0 and it will be completed at terminated at 3. Now at 3 the P0 is started and its burst time is 6. So 3 plus 6, that is 9. So now the next least value is 7. So at 9 process P2 will start. So P3, P0 and P2. So 0, 3 and this is 9. 0, 3, 9. So P2's burst time is 7. So that's why 9 plus 7, it will be executed up to 9 plus 7 means 16. So now the process means the next process, the next least process, that is 8 will start here. So the process P1 will start here. So 0, 3 and 9, 9 plus 7, 16, 16 plus 8, it is 24. So when we consider the FCFS and SJF, so the final value is same, 24 is same here. But the middle values, so the middle values, the waiting time values are changed because here we are using SJF, shortest job first. So based on the minimum burst time, we will consider the process first and execute that process first. Next we will consider the next least burst time value. So like that the Gantt chart is prepared, and by using this the waiting time is represented. So if you considered here, so what is the waiting time for P0? So for P0 it will be wait for 3, and for P1 it will be wait for 16, and for P2 it will be wait for 9, and for P3 it will be represented with 0, it will wait for 0. So now we will place these values in the waiting time. So like this. So 0, P3, 3, 9 and 16. So 0, 3 and here 9 and here is 16, 24. So by using this Gantt chart, the waiting time values for processes are represented like this. So for P0 it will wait for 3, and for P1 it will wait for 16, and for P2 it will wait for 9, and for P3 it will wait for 0. So like this we will calculate the waiting time for each and every process. So now we have the burst time values are there and waiting time values are there. So by using these two values we will calculate the turnaround time for each and every process. So coming to P0, so we will calculate the burst turnaround time for process P0. So here waiting time is 3 and the burst time is 6. So 3 plus 6, that is equal to 9. Similarly for P1, so 16 plus 8, so that is 24. So like that for process P2, 9 plus 7, that is 16, and similarly for process P3, 0 plus 3, that is equal to 3. So now we have the time waiting time values and the turnaround time values are there. So by using these two waiting time and by using turnaround time values of each and every process, we will easily calculate the average waiting time value or average turnaround time values. So in GATE examinations or any competitive examinations, question may ask in any ways. That means we need to find the waiting time of a particular process like P2, or find the turnaround time of process P1, or we'll need to find the average waiting time, or we need to find the average turnaround times. So sometime questions may ask like this also. So please draw the Gantt chart for about it. So like that also sometimes we questions will ask in competitive exams or in GATE, NET, SET examinations. So now we need to calculate the average waiting time and average turnaround time for these values. So for average waiting time we have the formula, that is sum of the values by total number of values. So sum of the values means 3, 16, 9 and 0 by total number of values mean 4. So now 28 by 4, that is equal to 7. So 7 is the average waiting time for these values by using SJF, shortest job first. Next, average turnaround time. So values are 9 plus 24 plus 16 plus 3 by total number of values mean 4. So that is 52 by 4, that is equal to 13. So in this way we will calculate the waiting time for each and every process, or turnaround time for each and every process. So after completing that, we will calculate the average waiting time and average turnaround time by using shortest job first scheduling algorithm. Thank you.